Hello.
Yes, sir, you're audible.
Yeah, so I see that there are five of you here. Is five of you here, or some of you are just switched it on and left? Okay. Yeah, so let me ask you a simple thing. Should I have the class today or not?
Yes, sir, have the class. And one more thing, just wait for 5 minutes, sir. I
Sure.
think someone may join.
Okay, I will wait for 5 minutes. Yeah. Okay, so let me just start in 5 minutes. Let me get some coffee and all for that. Hello. Yeah. So before I start, any questions, doubts, or the things that we are doing so far? So if not today, what we will be doing is that I will be giving you a problem, and I will ask you guys to put yourself in that person's shoes and try to solve that problem. How will you go about doing it?
Sir, one question before starting
Yeah.
the class. Sir,
Yeah.
I last class video was private. Can
Oh,
you
was
make
it private?
Yes.
Okay. I will then change it certainly. I mean, when did you check it? Today morning, is it?
Yes, yes.
Okay. Well, last class video was private. Okay, I will change it for certain. Just 1 second. No, it's now public. Can you just see? Check it once.
Sir,
Huh?
it's still private only.
Last class meaning which class? Hello?
Yes. NP vertex covering, yes.
This class.
No, NP completed what is covering. Okay, just 1 second.
It says video is unavailable, it is private.
Just 1 second. Let me just.
Yes, sir.
Oh, why is it private? Hmm. Yeah, for some reason, I don't understand this. Okay, anyways, I will then maybe have to reload it once again. Maybe some issue with say loading up of this thing. Oh, the video is in a draft state, whatever that means.
Okay, sir, no issues. You can do after the class also.
Yeah, I think let me do it after the class. Okay, I have to figure out what's going on. Yeah. Yeah, I think I have made it now public. Okay, good. Can we just check once before we start?
Yes, sir, it's working.
Okay. Okay. So, yeah. So the problem that I was thinking of is, I mean, I'm going to frame it in a slightly general context. Okay. So you are a say a company. Okay, you're working in company X. Oh, sorry, I'm not shared my screen. And you have various target customers. So now you know that there are target customers. Maybe there's people who read maybe Telegraph newspaper. Then maybe there are people who listen to so maybe DD News. Maybe they follow some I don't know, some social media post. So there are various people of different kinds, right? And there's a huge number of them. I mean, there's possibly m of these possible categories are there, and there are n people. So the universe, the target customer is omega, where size of omega is n, and there are these various categories of people. Now, of course, one person can be there present in multiple things, right? One person might be also be reading newspaper, Telegraph newspaper, also listening to DD News or something. Now your job is to, so now you can put an ad. Okay, the company can put an ad in or you can put a person dedicated to dealing with people, or how to reach out to people who are reading Telegraph News, or they can reach out to people who are listening to DD News, or they can employ someone whose job is to reach out to people who are following some kind of a social network page and all, right? So the what is the goal? Goal is, okay, find the least number of, so you can imagine that every person will require one person. Okay, one person. If the company decides to reach out to people who are reading Telegraph newspaper, he has to assign one person to that. Okay, so find the least number of person needed so that every customer is reached. Now see that if you put a person who takes care of Telegraph News and you have put a person who reads out to DD News, maybe one particular customer can be reached out from two different sources, but that's fine. All I need is every customer is reached at least through one source. Okay, at least through one person or one source. Now, can you solve this problem? What is the least number of person that you will need? Is this problem clear? Hello?
No, what's the
Hmm?
what is the least number of what?
Least number of
Can you
person.
repeat the statement again?
Can I refer the what?
Statement, problem statement.
Okay. So if a company decides to put an ad, say in Telegraph newspaper, he has to assign one person to take care of all the advertisements in Telegraph newspaper. If a person wants to whatever, have some maybe ads in DD News, then he has to assign one person to DD News, right? So they are like, you can call this them as like managers, right? One manager, two manager. There's another manager who might have to be given the role of just dealing with one particular social media outlet or social media forum, right? So the company, of course, don't want to put one manager at every possible sector. So that would be too costly. So the company wants to say that, okay, I would like to find out how is the least number of people that I need to assign, so that what is the goal? The goal is not to have one per this kind of channels, but the goal is that so that every person, every customer is reached through at least one person. So for example, if whoever is reading DD newspaper, so whoever is listening DD news, if that set of people is also reads Telegraph news, then you don't need to put a person in DD news, right? You will just say, okay, why don't I just target a Telegraph newspaper, and I will be able to reach out to all the people who are reading this news also. So similarly, I mean, so there are various optimization that you can do. So the question is that what is the minimum number of people the company needs to assign? Hello, is it clear?
Yes, sir.
Yes, sir.
So,
So here we
yeah, tell me.
so here we want to maximize the minimize the number of people that we are investing.
Right. Yes. Every person is a costly affair, right? Now, how will you solve this? Think of it yourself that the company has come to you and asked you to help them in solving it. How will you go about solving this problem?
So the first step in the last example we did in the last class, we first reduce it to a known NP complete problem and then prove that the problem itself would be as hard as an NP complete problem.
Right.
But in reality, we should do the other way around, right? We should show that the
first of all, okay, hold
hard.
on. There was this problem, as stated, is not a mathematical problem, right?
Yes.
First thing that you have to do is that you have to model it into a mathematical problem.
Okay, so no, I was just asking regarding
and then okay, then as I told you, I mean, just to recap whatever you are saying, yes. So one option will be to solve this problem. You want to maybe reduce it to some other known problem, known hard problem for which you can we know an algorithm possibly. But that would not prove that this problem is actually hard.
Yes. So first we need to prove that this problem itself is hard, right?
Yes.
So is there any connection the whoever send the DD news and the social media? Is there connection?
No, not that I know of. No, I have no. I mean, this is just something, a data that comes out, right? This is a typical thing that you. I mean, not maybe this question, but like you have taken interviews and all. What I mean, what do you follow? Where do you get news from?
No. Actually, I mean the whoever is sending the DD news. Is these people are manage the social media post?
No. They're all different.
Okay.
All the people are different.
But there is some intersection between these sets.
Yes, there are intersection between these sets.
So if the peoples from a group is a proper subset of another group, then we need one less number of managers.
Yeah, I mean, then it doesn't make sense to have that for the smaller set. Right.
So
Yeah, why will you then try to reach out to the smaller set even further? Sorry.
So can we just so I have an idea, just we have m labeled sets,
Yes.
and we want to, like, it's like a membership problem, right? We want to show that every element in X is a member of the some union of these m labeled sets.
Mm, right. I mean, so what do you mean by this last thing? I mean, M label sets. So what are the label sets? Let's say.
So like X1 being the people who read Telegraph newspaper, X2 being people who read DD News.
Yeah, maybe I will just use a different way. S1. Okay. So S2, S3. Right. So there
So
are, yeah,
I have m indexes, right? I want to,
you have M sets.
yeah, the index is 1 to
Each
m.
of them are subset of say 1 to n, right? A subset of the universe. Each of them are subset of the universe.
Yes. Now I want to find indices such that less number of indices,
Yeah.
like such that their union will be the universe.
Yeah. So what is it? What do you want to output?
I want to let's name a new set. I want to new set being like C or something I, a new set I such that
Okay.
the
Find
size of I such that the size of I is the least.
and size of I is least,
And the union of
and union over I
SI will give you the universe.
that is completely perfect. Do you guys follow this thing?
Yes, sir.
So this is the mathematical model. Okay. Now this is not the this is the optimization problem. Find an I and minimizes it. So what happens if you want to convert it into a binary problem, a decision problem? What is the decision version of the problem you can think of? See, unless we go to the decision version, we will not be able to understand the complexity very easily. What would be the ideal decision version of this problem?
We assign a membership of each of the n customers to each set 1 or 0. And we choose minimum number of n such that and we choose their membership in the overall union as the odd of all the memberships, and then we take an n that has to be 1 while minimizing the number.
No, hold on. You are checking for this one. You are giving me how to check this one using a decision problem, but that is not the decision problem.
We can assign some number on cardinality of I.
So right. So decision version will be the input would be says this one S1 to SM, the sets. Okay, this is what has been input, and the number K, and the output is 1 if there exists an I such the size of I is less than or equal to K, and union of SI I in I is equals to omega. So Devarshi, what you are saying was you are trying to get this statement into a binary form, but no, that is not the job of a decision problem. The decision problem is something that outputs 0 and 1. That's it. Either yes or no. So this problem, as it was told earlier, it says a find I such that I is least. So this is what we call as the optimization problem.
Yes. Okay.
Okay. And this is the decision version. Okay. Good. So now we are in the decision version of that thing. Now what? Now, by the way, I can just even tell you just for a little bit hint. Okay, so maybe before I tell you this one, can you somebody tell me how what will you do next? There are two things that you can do: an upper bound and a lower bound.
So we want to show this is NP complete, right?
Yeah, so actually I can give you that this problem doesn't have a NP solution, a polytime solution easily.
So we need to find a suitable problem such a way that that problem is equivalent to.
You want to prove NP complete. I mean, I'm telling you this one. So you have to first prove NP completeness of this problem. And you also want to reduce this problem, or maybe I would not say reduce, solve this problem using other problems, other known problems. These are the two things that you would like to do. Now think about it. How will you go about it? How will you use it? How will you solve this two? These are the two parts. So sometimes we can call this one is called the lower bound problem, LB, because this is like I'm going to say that this problem cannot be solved in polynomial time kind of stuff. And this is called the upper bound problem because I am going to give you a solution using some other thing. Okay, but how will you prove this two?
Sir,
Yeah.
while proving NP completeness, we will we don't have exact way of proving NP completeness, right? So we will prove that using reduction, right?
Yes, we will prove that during reduction.
So what is the need of second one here?
So this one is incompleteness. Okay, fine. But what does incompleteness say?
NP completeness actually first thing is we have
No,
to prove.
I mean, after you solve by NP completeness, what will you why do you prove NP completeness? What happens after that? You solve NP completeness kind of to give a guarantee that see this problem is very hard, right? That this problem is hard, so don't expect me to solve a polytime algorithm. This is what NP completeness is basically saying. I mean, this is the hardest problem is NP, so this problem is harder than any other problem like SAT and vertex cover and whatever and whatnot. So how can you expect me to solve it in polytime? Or one should not expect to solve a polytime algorithm. But then one should not expect to solve a polytime algorithm is an escapist thing. Your company has asked you to help them. Then what will you do? You will just say that, oh no, I cannot do it because it's NP complete.
We need to find a exponential but an efficient way to compute the problem.
Yes, that is one option. Maybe they find an exponential and but try to do efficient.
So the idea, yeah, we can convert it to a non-problem and non-NP complete problem which has a good solution already.
Or you can prove it to an NP complete problem which has a heuristic solution. Okay, there are lots of heuristic algorithms that are there in life, like SAT has the SAT solvers, ILP solvers, and so on and so forth. You convert them and use heuristic algorithms to solve it. So in that case, either you have to come up with that algorithm all by yourself, which is usually very hard, or just reduce your problem to some other problem. Is this fine?
Yes, sir.
Yeah, so it seems that I have messed up in some way because I did not realize that I have a meeting today. So as it turns out, I have a
Sir.
meeting. Yeah.
Just one thing, I had a question regarding the terminologies. NP completeness means which problems are equally hard, right?
They are
SAT and
equally
IELTS are
hard to
equally hard.
what? No, hold on. Equally hard to what?
The known NP complete problems like the CSAT or ILP.
That is not the definition of NP complete problems. Okay. So NP complete is NP complete. Okay. So L is NP complete. What does it mean is that L is harder than any other problem in NP.
Okay, okay. So that was the query, that whether it is an equal statement or a harder statement only.
It's harder, but since if I say that L1 is NP complete and L2 is NP complete, then what is happening here?
So you probably said in the last class that there can be some problems which are not even NP, right? Like harder than that in some sense.
No, they are all in NP. Okay, but L1 is NP complete, L2 is NP complete, means L1 is harder than L2, L2 is harder than L1.
Yes, but can there not be some problems that are not even NP, like we
Okay,
cannot
so there is
so-
this notion of so this is harder. So in that respect, okay, in that case, I should be very careful here. You are right. So this
Yes,
is not
sir.
what is NP complete is. So that is called NP hard.
Yes, that's what
Okay.
I'm saying. Right.
Now NP hard and NP complete are basically same. Okay, so what is NP complete? NP complete are those problems in NP. Those are harder than anything else.
Okay, so the problem being in NP would imply that, yes.
Yeah, so yeah, you are right. So this is NP technical, this is NP hard definition, this is NP complete. Now NP hard, if it is NP complete, if two things are NP complete, that means L1 is harder than L2 by definition of NP complete.
Yes.
Similarly, L2 is harder than L1 by definition of NP complete. So which basically turns down to that L1 and L2 are basically similar. So they are equivalent up to polynomial reduction. Okay. So this class of NP complete problems, therefore all of them are same complexity. Okay, now you said, okay, if all of them are same complexity, then why are we reducing one to the other? Particularly when we try to solve the upper bound. It is because have you ever tried to kind of do some carpentry work or something like that? And you see that, okay, I need a screwdriver, but I don't have the exact screwdriver, but I will make use of this screwdriver, whatever I have. Now, why don't you use a proper other screwdriver, which is perfect for you? Because for that, you have to go and make the screwdriver. For that, you have to go and buy the screwdriver. Instead of that, you kind of have invested money in a set of screwdrivers and use them for all of that, right? So similarly here, while all the NP complete problems are equally hard, people in has so while so all NP complete problems have same complexity, but it is a big but, there exist a handful of problems which researchers have worked on for quite some time, for a long time. And that means for these problems, so for these problems, there are a nice algorithms. Now, these nice algorithms are not necessarily always correct algorithms, but they're nice algorithms. They're nice in the heuristic sense and all. So these are the problems. So if I have a problem, and so what are these problems? So SAT is a problem of this form, for which you have SAT solvers. You have ILP is a big problem of that form, for we have ILP solvers. There are some more of them. Okay, I don't want to go into the details of that, but maximum cut, max cut has a nice solution and all. But so when you are given a problem, when you come across a problem, although like if you prove this statement, if you prove the first statement, then you will end up proving that this is NP complete. So this is as hard as SAT. But that's not the end of the day. I have to solve it still. Either I have to sit down and try to find out a solution for it, or I can use, I know that that problem is as hard as SAT. People has for 40 years worked on coming up with algorithms of SAT. They are beautiful algorithms for SAT, or they are beautiful algorithms for ILP. Why don't I therefore use those algorithms to solve my problem? Okay, so is this idea clear? Why would we like to do this part? Hello.
Yes, sir, it is clear.
Yeah. Okay, so I would so I unfortunately I think I have to go now because I have a meeting. Okay, but it is good that actually if I stop the class right now, and I will request you guys to please not go anywhere. Instead, try to solve these two problems. First of all, prove that is NP completeness. Okay, I can tell you that okay, you can go and search in the internet and you'll get it. But for whichever thing that we have proved, so what we have proved SAT, ILP, vertex cover. These are the things that we have kind of proved to be NP complete. You can use them to prove this is NP complete. And on the other hand, I want you to reduce it in the other direction and use an ILP or a SAT solver to solve this problem. So there are the reductions of two directions, and both the directions of reductions is something that I want you to do. Okay. Anyways, I will meet you again on Wednesday. So that time we will be discussing on this thing. I hope that you guys will have some idea of this one. Regarding this particular problem, let me tell you a hint. This problem is called set cover. This is called the set cover problem. So what I'm asking you is to first prove that set cover problem is NP complete, and next you prove that set cover can be solved using ILP or SAT solvers. Okay, so is this problem clear?
Yes, sir.
Yeah.
This
Yeah.
problem is clear, but I had a query regarding the SAT problems.
Yeah.
So in SAT problem, we give a input of clauses, conjunctive normal form of clauses,
Yeah.
variables, and we check whether it evaluates to 1.
Yes. Whether there exists a
Can there be
evaluation
any
to 1.
constraint on the, like say, number of ones?
No. Okay. So in the general setting, no. Okay. In the
Okay.
general SAT problem, there is nothing like that. Okay. But these are variants of SAT which has also been studied. Okay, is this SAT satisfiable when the number of ones is more than something or less than something or something like that?
Okay.
Okay, so they have been
So
studied.
if we are working with reduction, we should work with the norm standard.
You just work
form
with the
of
normal one.
SAT. Okay.
Yeah, you just work with the SAT or 3-SAT thing, ILP and vertex cover. Okay. Yeah, sorry, I have to leave now because I have a meeting which I kind of forgot about it actually. But good. So why don't you guys think about it, solve it, so that in the next class on Wednesday we can start from this. Okay. Okay. So I think I'll see you on Wednesday then.